Hello guys, and welcome back to chemistry class. And so today we're starting another new topic. This is chemistry, and today we are going to be looking at periodic table. We're entering into another new topic called periodic table. We are going to have an interesting time studying this. This is usually one of the best topics students like in chemistry. All right, and I intend to also make it very interesting for you to learn and understand perfectly well. All right, because there are a lot of misconceptions. All right, when it comes to this topic. All right, so please, I'm going to clear all of those for you. And of course, do not forget that this video tutorial, of course, is brought to you by the O3Schools JAMB app. It is the best CBT practice app you can ever want to have on your phone. All right, it's available for Android phones. It's available for software, that is for PC. If you have a laptop, you have a computer at home, which is even much better. All right, but the one on the phone is even good because you can practice anywhere and at any time. It has all the past questions you can ever want to have in this life. All right, as it pertains to JAMB, it has all the past questions that you need to succeed in your JAMB. All right, so all the recent past questions, even the one of last year, is on the app, so you do not need to worry about past questions at all for all subjects. So all subjects are on the app, and once you activate the app with 3,000 naira, you are going to have all of those subjects. So you'll be at liberty to pick the 4 subjects that are corresponding to your combination. All right. So many features on the app. One, there's a question search feature. You can search for questions per topic. So if you go to the app now, go to question search, type periodic table. All the questions that will come out under periodic table will come out for you. So that means that after you have finished a particular topic, finished studying a particular topic, and you want to study with questions, so you don't need to bug yourself with other irrelevant topics. Only periodic table will be streamlined for you. You have all the past questions, you answer them, it will build your confidence. Another wonderful feature, of course, is the classroom feature. The classroom feature is there for you to learn and practice. So our AI powered tutor is there to assist you, to lead you to the right answers as you study. Also, there's also another wonderful feature called the UTME challenge. The UTME challenge is a bomb. It's a challenge that will conduct for all students writing JAMB every year. So all students are competing with all other students that are writing JAMB, just like the way your exam will be. So you are facing questions. You are going to see what your scores at the end of the challenge every week till 1 week to JAMB exam. We'll do that. We'll conduct that challenge for you to win prizes. Not only to win prizes, because you are seeing your score every week, you will see, of course, that you see the areas that they are performing poorly and the areas you need to improve upon. So you see the areas that you are very very strong at, and so that you can reserve more time to learn or practice those areas where you have weakness. So wonderful features on the app. Activation is just 3,000 naira. 3,000 naira to pass your JAMB. That should be the cheapest anybody should do. All right, so let's head back to what brought us here today, which is the periodic table. Now, the periodic table of chemical elements was first designed. The periodic table of chemical elements was first designed by a man called Dmitry Mendeleev. All right, so he was the first person to first design the periodic table of chemical elements, and he did this in the year 1869. So please put that at the back of your head. So Dmitry Mendeleev in 1869 first designed the periodic table of chemical elements. Now, the problem is that Dmitry Mendeleev periodic table had so many gaps. His periodic table had so many gaps, which he predicted, of course, to be filled by undiscovered elements. With certain properties. So his periodic table that he designed in this 1869 had so many gaps. There were so many gaps on them, and he predicted that those gaps were to be filled by undiscovered elements with certain properties. Now, the problem with Dmitry Mendeleev's periodic table was that he had arranged the elements in the periodic table according to the increasing order, according to the increasing order of their atomic weight. Or the one we call atomic mass. All right. atomic weight, atomic mass, or the one we call formula weight, or the one we call relative atomic mass, or the one we call mass numbers. All this mean the same thing. All right. So the problem with Mendeleev's periodic table was that he had arranged what is periodic table, the element in the periodic table, in the increasing order of their atomic weight or mass, their formula weight, relative atomic mass, or their mass number. So this seemed to be a problem. But this had to be revised by another man called Sir Henry Gwyn Jeffrey Moseley. Sir Henry Gwyn Jeffrey Moseley. All right. So he revised what the periodic table in the year 1913. He revised the periodic table and then redefined it to say that what the elements are a periodic function. He said that what elements, let me write that out. Elements are a periodic, function of their atomic number. All right. So Sir Henry Gwyn Jeffrey Moseley was an English chemist or physicist. And in 1913, he revised what the periodic table and said that what elements in the periodic table are a periodic function of their atomic number. That means that what elements are not supposed to be arranged in the periodic table according to their increasing atomic weight or mass, formula weight, relative atomic mass or mass numbers. Instead, they are to be arranged in the periodic table according to their what atomic number. And this law is what we now call the modern periodic law. The modern periodic law. All right. So the modern periodic law said that what elements are a periodic function of their atomic what number and not their atomic weight, mass, or any of this. All right. So remember that all this means the same. Okay. So elements are a periodic function of their what atomic number. This was what we now know, make known today. Today, as you and I are talking or as learning together, that's what we now know to be called the modern periodic law. Elements are a periodic function of their atomic number. So I'll go over that again. Dmitry Mendeleev in 1869, right, designed a periodic table of chemical elements in which he arranged the periodic table in increasing order of their what atomic what mass or mass number. All right, but of course it was revised by Sir Henry Gwyn Jeffrey Moseley in 1913 when he was revised the periodic law to say that what elements are a periodic function of their atomic number, and he did this while he was studying the X-ray spectra, the X-ray spectra of some elements. All right. So while he was studying the X-ray spectra of some elements, he discovered that what no elements have to be what arranged according to the what to their what atomic number and not their formula weight or relative atomic mass. Hope you are getting me now. I'm sure that part is very, very clear. So that is the history of what or the periodic table. Of course, that you should what you put at the back of your mind. Now, having seen this, let's now move to the next part of our discussion, which will be, of course, groups or period. Groups and period. Actually, groups and period. Now, please, if you have not liked this video, please, what you are doing is wrong. Liking this video will make other students like you easily find the video. So that button that looks like this now, just click on it. Just like it. All right, please. Then if you have not subscribed to this channel, you are doing yourself a great loss, because as you are subscribing to this channel, once we release a new video, you'll be notified on your phone that we have released a new video. In that way, you can be able to follow our tutorials episode by episode. So it's to help you, and subscription is free. Subscription to this YouTube channel is completely free. Any video we do here is free. It's not sold. So please make sure you want to click on that subscribe button right away. Now, let's say groups and period. Groups and periods. All right. Now, very importantly and very quickly, know that what in the periodic table there are 7 horizontal rows. 7 horizontal rows. 7 horizontal rows that we call what? The periods. All right, so like we have rows like this. You see a periodic table, one is being shown right now. All right, one is being shown right now. 1, 2, 3, 4, 5, 6, 7. All right, so these are rows like this. These are rows. You know, you now have something like this again. I got some. So these are rows. These are the rows. All right, so we have 7 horizontal rows that we call the periods. All right, in the periodic table, there are 7 horizontal rows called period, and then we have 18 vertical columns. 18 vertical columns that we call the what? The groups. All right. So the periodic table, that means a complete periodic table, we have 7 horizontal rows that we call periods, and then 18 vertical columns that we call what? The groups. All right. So this is a complete what? Periodic table. 7 horizontal rows called period like this, as you can see. Then 18 vertical columns. All right. So you see what? After this, you see, I think you see another one again. You see another one. Then you now have what? Boxes here, like this, like this, like this. So these vertical ones are called the what? The groups. This one that run this way, they are called what? The groups. All right. So these are like the transition elements, and then you now have from and so on and so forth. Okay, so the vertical columns, they are 18 and they are called what? Groups. While the horizontal ones, the one that run this way, right, they are called what? The periods. All right, for some of you that don't know, this is vertical, then this is horizontal. All right, so please note that at the back of your mind. All right, so now, having seen this now, the next thing to quickly know is the periods. Let's talk about the periods to start with. The 7 what? Horizontal rows called the periods. All right, let's see the periods quickly. Now, periods. Now, the periods are numbered from 1 to 7, isn't it? The periods are numbered from 1 to 7. All right. Now, and the period designated to a particular element, right, will correspond to the number of electron shell or energy level of that element. Now, the number of period designated to a particular element, right? If you say an element is in period 3, right, it will correspond to the number of electron shell or energy level that element what has. Please, we have started the topic and it's very interesting. So these are example. Anything I say from now is an exam question. So please open your ears down. Open your ears down. All right. Now, periods are numbered from 1 to 7. And of course, the number of what the number designated, the number of period designated to a particular element correspond to the number of electron shell or energy level that what element what has. Now, for example, if you say that an element belongs to period 3 or to period 4, what it means is that that element has what? 3 electron shells, or what? The energy level is what? Is 3, and to correspond to what? Of course, the K, L, and M what? Shell respectively, because this is what? 3 what? Energy what? 3 electron shell. Now, I've talked about electronic configuration before. Most of you skip some videos and skip some videos and skip some video, and you're doing yourself. We have talked about electronic configuration in detail. There's no way you watch electronic configuration and you have any problem when it comes to that topic. So please, I'm not going to talk about this too much again. Anything about electron shell, energy level, electronic configuration, I'm not going to go back to it again. I make sure I painstakingly taught that topic because we are going to need it in what? In further topics. So please make sure you go back and you watch all the episode by episode. And make sure you share this video to your friends. I don't know why you are being stingy. Please, if you have opportunity to watch this video, share to others so that they can also learn and follow. So now, we're talking about periods, and we said that the period designated to a particular element will correspond to the number of electron shell or energy level of that element. That means if we say an element is in period 4, it will have what? 4 electron shell, like KLMN. All right, and what? Of course, it will correspond definitely. So the number of period corresponds to the number of what? Electron shell. All right. So having known this now, let's now move to the groups. Let's move to the groups. The groups is where we have a lot to talk about. Groups. All right. So now, moving from the left, from if you have a periodic table like this, okay. So you know it goes like this now. So one is being shown on your screen right now. So I'll just try and while editing the video to make sure that I use marker to what to be or showing you as we proceed. So just make sure you are looking at the screen throughout. Now the groups are numbered from 1 to what 18. All right. So this is the IUPAC system. The groups are numbered from what? From 1 to what? 18. Moving from what? From the left to the right. They are numbered from what? The number from what? 1 to what? 18. This is what? The IUPAC system. So actually, there are 18 groups in the periodic table and not 8 groups. So if you are asked a question, how many groups are in the periodic table? The first option you should be looking for is 18, not 8. So I will tell you why soon, because some people erroneously say there are 8 groups in the periodic table. Why they say that is I'm going to talk about it later on before the end of this video. All right, but by the IUPAC system, there are 18 groups. They are numbered from 1 to 18. The groups are numbered from 1 to 18, and of course, this is by what? By IUPAC, the International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. Some of you will answer that question now, you feel it. All right, so International Union of Pure and Applied Chemistry. Let me write that out. IUPAC means International Union of Pure and Applied Chemistry. All right, so that is what IUPAC what means. International Union of Pure and Applied Chemistry. So please put that at the back of your head. Now, having known that, now these numbers of the group, number from 1 to 18, can also be what number as I'm going to have what 1A, 2A, then you have 3B to what 7B. All right, 1A, 2A, 3B to 7B. Then we have 8, 8, 8. I'm going to be showing you right now as you're watching this video. 8, 8, 8. Then we have what 1B to what 2B, or 1B, comma 2B, 1B, 2B. Then we now have 3A, 3A to what 7A. Then the group 0. All right. So now we say the groups are numbered from 1 to 18 by the IUPAC system, and we say, of course, they can also be what numbered as this: 1A, 2A, 3B to what to 2B, 8, 8, 8, then 1B, 2B, then you have 3A to 7A, then group 0. So the 1A to 2A is what I just highlighted for you right now. That is 1A to 2A. Then the 3B to what 7B is what I just highlighted for you right now. Then the 888 is what I just highlighted for you right now. Then of course 1B to 2B is what I just highlighted for you right now on the what on the periodic table. And then of course 3A to 7A is what I just highlighted to you right now. Of course, group 0 is very glaring. That is the last group in the what in the periodic table. That means that what that means that what that group 0 is also what called what is group what is group 18. Group 0 is group 18. All right. So now that is how what the periodic table are what is numbered. The groups they are numbered from 1 to 18 by the IUPAC system. So they also number like this: 1A, 2A, 3B to 7B, 888, 1B, 2B, 3A to 7A, then the group 0. Say group 0 also correspond to what? To group what? To group 18. To group 18. Now let's start to look into what the elements that are in these groups. All right. So the first of them that I'm going to look at, of course, is the D block elements. The D block elements are from what? From 3B to what? To 2B. The D block elements. So they are called the transition what elements. So we have what? Elements from 3B to 2B. From 3B to 2B, they are called the transition elements. They are called the transition what element? Element from 3B to 2B. They are called the transition element. Please Take note of it. From 3B to 2B, they're called. They're not going to ask you in exam question from 3B to 2B because most people don't even know how this is numbered. All right. So, but of course, you will know that what they are also called the D block elements. The D block elements. So the transition elements are also called the D block element. Please take note of that. This is an exam. This is the way they will ask you. They will, instead of putting 3B to 2B, you will see D block in your exam questions. So the D block elements are also called, they are called what? The transition what element. And why are they called the D block element? They are called the D block element because their outermost shell, what lies in the d orbital. So you are hearing about orbital again. Orbital, if you do not know anything, if you don't know what orbitals are, go back to our video on electronic configuration and learn it, and go and watch that video very well. Go and watch it very well because I'm not going to talk about it again. So now the D block elements are the transition elements. They are called the transition elements. All right. They are called the D block element because their outermost shell lies in their what? So their outermost what? Electron rather. Their outermost electron what resides in the what? In the d orbital. The outermost electron resides in the what? In the d orbital, and that's why they are called the d block element. And they are from what? 3B to what? To 2B. So those are what? Those are the transition elements. Then of course we now have what? I'll talk about what? 3B from here all the way to here. Now we also have what? From 1A to 2A. This 1A to 2A, they are called the S block elements. They are called the S block element. These ones are called the D block. The transition elements are called the D block element. Why 1A to 2A are called the S block elements. Now, why are they called the S block element? They are called the S block element because their outermost electron lies in the S orbital. In the S orbital. They are called the S block element because their outermost electron lies in the S orbital. All right. So if you want to know what orbitals are, please go and watch our video on electronic configuration. And if you're not sharing this video, and if for peradventure you do not like this video, what you are doing is very, very wrong. Please click on that like button now as you are watching this video so that we can all progress together. Now, so the S block elements are called S block elements because the outermost electron resides or lies in the S orbital, and they are what? They correspond to what? This 1A or 2A. 1A, 2A. I'm going to highlight it for you right now as you are following. So as I'm highlighting, in case I'm not able to show you the full periodic table at a glance, just make sure you have your own periodic table by your side while you are studying or watching this video, so that I can easily know where I'm highlighting. All right, so that is that. So the S block element they are from 1A to 2A. Then of course we now have another one called the P block. The P block elements. The P block elements are so-called P block because their outermost electrons reside in the P orbital, right? Their outermost electron, remember we have SPDF, right? So excuse me. So their outermost electron reside in the what? In the P block. So in the P orbital, the outermost electron reside in the P orbital, and that's why they're called the P block elements. They're called the P block element because their outermost electron lies in the P orbital. So, and of course, they correspond to what? 3A to what? To 7A, right? So, and also what? The group 0, of course. Now, so they correspond to what? 3A or to 7A and the group 0. So all that element from 3A to 0, they are what? They are called the P block elements. Then, of course, after knowing that, the next thing to know is the F block elements. I've talked about the S, the P, the D block. I talk about the S block. I talk about the P block. There's many one orbital I will not talk about, which is the F the F block element. Now, the F block elements are divided into two. We have the lanthanide series. Lanthanide series. All right. This lanthanide series correspond to what? Element 57 to 71 in the periodic table. Lanthanide series, and then we now have the actinide. actinide series. This one, they correspond from what? 89 to 103. So elements 57 to 71 are called the lanthanide series, while the 89 to 103 are called the actinide what series. Now, together, these two, all right, this lanthanide and actinide series, together they are called the inner transition element. Inner transition element. All right, together they're called the inner transition element. Please let me take this off so that we can have more clarity. The board seems to be too congested at this point. All right, so as I've said rightly, I said that what the F block what elements, F block, we're talking about F block now. All right, the F block element, we said that what they're divided into two. We have what the lanthanide series corresponds to element 57 to what? 71. Then we have the actinide series corresponding to what? 89 to 103. All right, and we say that what they are called the F block element because their outermost electron lies or resides in the F orbital. Their outermost electron lies or resides in the F orbital. That is why they are called the what? That's why they are called the F block. And together, these two together, the lanthanide and the actinide series, they are called the inner transition metals. They are called the inner transition metals. So that will be what the end, because SPDF. I talk about S, I talk about P orbital, D and F and the F block. S block, P block, D block, F block. All right. So of course, see. So let me just draw a sketch of the periodic table. So if you have that periodic table like this, I have what 7 rows, horizontal rows here. This 1, 2, 3, 4, 5, 6, 7. All right, then you now have what, there's another one here like that together. Sorry, I'm just drawing a sketch so that you see what I'm talking about. All right, so then you now have the transition. This block here is the S block. This first block here is the S block. Then of course you now have what, the horizontal, the transition metals. The transition metals, that one that is now like this. All right, so this one here is called what, the D. This is the D orbital, or the D block. Sorry, this is the D block. What? D block, and then now have what, another one like this that goes like this from 3A to 7A now. All right, so all the way down. All right, so from 3A to what? Okay, so we now have what, from 3A. Sorry, here from 3A to 7A, and the group 0, of course. All right, so this one is called what, the P block. All right, so I've seen the S block, the first block, then the transition what element, the D block, and then of course the P block. Now there are some that are separated, they are separate, they are just down here. They are down here. You see here, you see two boxes here. All right, divided into two. We have lanthanides, then we have what, actinides. All right, so those ones are called what, the F block what element, and we say they are called the F block element because their outermost electron resides in the what, in the F orbital, So that is that. I talk about what the F block what element that is divided into two, lanthanides and the what, and the actinide what series. Okay, so now what we do to know, what we need to know is that what elements that belong to the same group in the periodic table are called what? We have done this before in the previous episode, all right, of our teaching. Elements that belong to the same group in the periodic table are called congeners. All right, elements that belong to the same group in the periodic table are called what? Congeners. And then know that what elements in the periodic table are divided into three main categories. Elements in the periodic table are divided into three main categories. One, we have metals. Then two, we have non-metals. And then three, we have metalloids. All right, so elements in the periodic table are divided into three main categories. We have metals, non-metals, and the metalloids. All right, you know what metals are, you know what non-metals are, right? The metalloids may be the one that is a bit confusing. So metalloids are in between metals and what and non-metals. They have what kind of have what both what properties. All right, now some commonly recognized metalloids. Some commonly recognized metalloids include boron, right? We have boron, we have silicon, we have germanium, we have arsenic, we have antimony, we have tellurium. So these are what the commonly recognized metalloids. Metalloids. These are what the commonly recognized what metalloids. Boron, silicon, germanium, arsenic, antimony, and tellurium. They are what? These are the most commonly recognized what metalloids, right? Now these metalloids, they take a position of what? Of a staircase from what? From the P block. All right. In the P block, if you see in the P block, you see something that looks like what? Like a staircase there. All right. So they fall what on that staircase. They are said to separate metals from what non-metals in the periodic table. The metalloids are said to separate what metals from non-metals in the periodic table. So to the left of what that staircase that look like this, I mean something like this. Something like this. All right, so you see something like that. So you have boron somewhere, boron, you have silicon, you have what arsenic, antimony, and so on and so forth. So this staircase is what separates metals from non-metals in the periodic table. So to the left of this staircase are what? Metals. To the left are metals, while to the right are non-metals. All right, so that is what you need to know about what that. All right, so now that staircase is what separates what metals from non-metals. All right, now they haven't known that what there are some other less commonly recognized what metalloids. All right, they are less recognized as metalloids, but they are still metalloids anyway. So example is carbon. We have aluminium. We have selenium. All right, all these ones that are less commonly recognized as metalloids. We have polonium, and of course astatine. This one they are less commonly recognized as what? As metalloids. While this one are the one that commonly recognized as what? As metalloids. All right. So we have said that what elements that belong to the same group in the periodic table are called congeners, and then we say what elements in the periodic table are divided into three main categories: metals, non-metals, and metalloids. All right. So I talk about some commonly recognized metalloids. Talk about what some less commonly recognized metalloids, and I talk about that staircase that separates metals from non-metals. All right. They separate what is metals from non-metals. So to the left of that staircase, they are all metals, while to the right are what are non-metals. So I believe that what we have what done a lot of elucidation on the groups and the periods of the periodic table today. If you do not understand any part for any reason, please make sure you drop what your comment in the comment section, and I'll get to it immediately. My name remains Olabi, thank God, and I'll see you in the next episode.